Hello everyone. Today we are going to conduct the experiment number 5, that is study of 3-port circulator. So this is actually the experimental setup. So here we have connected the microwave test bench setup, that is klystron power supply, klystron source, isolator, variable attenuator, frequency meter as well as slotted line carriage. And according to this experiment, for the slotted line carriage we are going to connect the probe to the CRO, okay, and we are going to connect the slotted line carriage to the circulator. So in the circulator we will be having the 3 ports. So in the circulator we will be having the 3 ports. So port 1 is connected to the slotted line carriage, and the port 2 is match terminated, and the port 3 is also match terminated. Okay, so next we are going to conduct the experiment. So this is actually the experimental setup. So when it is connected to the, suppose if we consider this circulator, here this is actually the port 1, port 2 as well as port 3. Okay, here they have given the direction. So if we consider this as the port 1, this is the port 2 and this will be the port 3. So here port 1 is connected to the SLC, port 2 is match terminated and port 3 is also match terminated, and SLC in the right extreme corner. So here what we have to do is, so first we need to move the slotted line carriage. So once we connected with the circulator port 1 to the SLC and port 2, port 3 are match terminated, so we need to move the SLC to get the maximum voltage. So here the maximum voltage Vmax is equal to 760 millivolts. So next we need to take the minimum also. So if we keep on moving, so we will get the minimum voltage. Minimum voltage is 460 millivolts. So similarly we have to connect port 2. Next we need to connect the port 2 to the SLC, and port 1 is match terminated and port 3 is also match terminated. We should take the Vmax as well as the V minimum. So Vmax will get that as 120 millivolts, and V minimum is, so we should take the V maximum as well as the V minimum. Okay, V maximum as well as the V minimum for port 2 also. Like that we need to connect port 3 to the SLC, and port 1 is match terminated as well as port 2 is also match terminated. So and we need to take again the V maximum, V minimum. Okay, so once we take the readings, so we'll check it with the readings. Here you can observe for the first port we have taken the V minimum is 168 millivolts, V maximum is 196 millivolts, and similarly for the second port V minimum is 118 volts and V maximum is 136 millivolts, and similarly for the third port also V minimum is 130 millivolts and V maximum is 180 millivolts. So we need to find out the VSWR for 3 different ports. For port 1, VSWR 1, or we can call that as rho 1 is equal to Vmax 1 by V minimum, and rho 2 is equal to Vmax by V minimum, rho 3 is equal to Vmax 3 by V minimum 3. Okay, so once we find out this VSWR, then we need to find out the reflection coefficient. So reflection coefficient is equal to VSWR minus 1 divided by VSWR plus 1. Okay, so that's why we have taken rho 1 minus 1 divided by rho 1 plus 1. And that is equal to 1.167 minus 1 divided by 1.167 plus 1 will get 0.072. And similarly for the port 2 also, reflection coefficient 2 is equal to rho 2 minus 1 divided by rho 2 plus 1, that is equal to 1.14 minus 1 divided by 1.14 plus 1. So we will get 0.078. Similarly, for the port 3 also, reflection coefficient 3 is equal to rho 3 minus 1 divided by rho 3 plus 1, that is equal to 1.13 minus 1 divided by 1.13 plus 1. So we will get 0.061. Okay, in order to find out the insertion loss as well as the isolation loss, so we need to connect the circuit like this. So for the klystron power supply to the klystron source, so next we need to connect the port 1 to the circulator, and 2 will be connected to the detector, tunable detector mount, and from that we are going to connect it to the CRO. So and the port 3 is connected to the match termination. Okay, so and we are going to find out the readings. Here we have taken port 1 is connected, 2 is the detector mount is connected to the, and probe is connected to the CRO, and port 3 is match terminated. We are getting the voltage. This will be considered that as V2. So here we are getting the voltage nearly 12.5 millivolts. Okay, and in order to find out the voltage 3, so we need to connect the components like this. Circulator 1, port 1 is connected to the supply, klystron power supply. So and the 2 will be connected to match terminator, and the port 3 is connected to the tunable detector. From the tunable detector we are going to connect the probe to the CRO, and this is actually the connection. So here port 3 is connected to the detector, and from the detector we have connected the CRO, and we are getting the voltage. The maximum voltage we are considering V3 as nearly 10 volts. Okay, sorry, not 10 volts, 10 millivolts. Okay, so next we need to find out the V1. So this is actually the V1 connection, voltage connection, means just we have to remove that circulator. So and directly we will connect it to the tunable detector mount to the CRO, and we are going to find out the voltage. So this is actually the setup for the microwave setup in order to find out the voltage 1, that is V1. So here we are going to measure the V maximum voltage, that is V1 is equal to, so nearly we are getting 100 millivolts. Okay, so by taking all the readings we are going to find out the insertion loss as well as the isolation loss. So next we'll see the calculation part. So once we find out all the voltages and we find out this VSWR as well as the reflection coefficient, next we have to find out the insertion loss. So insertion loss will be considered with respect to the two ports. So I1 is equal to 20 log of V1 by V2, and I2 is equal to 20 log of V1 by V3. So 20 log of, so V1 we have taken that as 686 millivolts divided by 27.6 millivolts, will get 27.9. Okay, and with respect to the port 3, isolation loss will be, insertion loss will be taken as 20 log of 688 divided by 25.6, will get 21.58. Sorry. I1 represents 20 log of V1 by V2 as the insertion loss, and I2 is equal to 20 log of V1 by V3 represents the isolation loss. So next we are going to find out the S parameters. So S matrix will be represented as S is equal to, this is 3 cross 3 matrix, S11, S12, S13, S21, S22, S23, and S21, S31, S32, and S33. Okay, so in order to find out that, so here S11 is equal to VSWR 1, gamma 1 is equal to 0.077 we have found in the last calculation, and S22 is equal to the VSWR2, that is 0.078, and S33 is the VSWR3, that is equal to 0.061. And in order to find out the S12 is equal to S23, that is equal to S31, that is nothing but V2 by V1, that is nothing but 25.6 divided by 688 millivolts, will get 0.037. And S13 is equal to S12 is equal to S31 and S21 that is equal to S32, that is nothing but V2 by V1, that is equal to 27.6 divided by 688, that is will get 0.0401. Okay, so finally we are going to tabulate according to the 3 cross 3 matrix. Thank you.